Good afternoon, ladies and gentlemen. My name is Kenzie. The paper that I'll be discussing with you today is plasma generation using the electric barrier discharge reactor for phenol degradation in Batik wastewater. The research is done by Afrisa Nimatu Saada, Kenzie Budi Saputra, Muhammad Dhani Fadoli, Vicky Hermansyah, and Nita Arianti. Batik is considered as one of many UNESCO's intangible cultural heritage of Indonesia that continues to develop. It has been developed for hundreds of years. The cultural heritage has its own economic value and market. The enthusiasm of Indonesians for batik is getting higher along with the time. However, batik industries are not free from problems. 81% of batik industries in Indonesia do not treat their wastewater. The wastewater mainly comes from the coloring process, which leads to various negative environmental problems if not being processed. This occurs because the wastewater contains organic compounds, suspended solids, dyes, chromium, sulfide, ammonia, fats, oil, and phenolic compounds. Phenolic compounds are toxic compounds even at low concentration. The compounds are hematotoxic, mutagenesis, and carcinogenesis. Therefore, the phenolic compounds need to be degraded. There are various methods that has been used to degrade the phenolic compounds, such as photolysis, coagulation, and electrophoton. The previous methods have been proven as ineffective. Therefore, an effective degradation method is needed to reduce the levels of phenolic compounds in batik industry with water. The effective method of it is plasma electrolysis with the help of the electric barrier discharge reactor. The method and reactor are selected since it has the largest efficiency compared to the other methods and reactor types. The research method is shown in the screen. First, the reactor is set. Second, reactor performance test is done. Third, we did the current and voltage testing. This is where the electrolysis process occurred. After the process is done, hydrogen peroxide concentration and yield is measured. Phenol concentration is also measured too. Last, ANOVA analysis is done. Next, we move to the result and discussion. First is the electric barrier discharge reactor characterization. The characterization is done by measuring the electric current voltage and observing the plasma formed. We apply three treatments: the iron sulfate catalyst, iron oxide catalyst, and no catalyst. After the characterization process is done, the phenomenon observed is similar. The current will increase as the voltage increases as shown in the figure. This phenomenon happens because the electric voltage affects the number of electron charges and the electric field generated by the reactor. The increase of electron charges accumulated at the inner electrode causes the electrons to have enough energy for the ionization process. The ionization process causes the formation of plasma between the two electrodes. However, the plasma color is influenced by the amount of voltage used and the amount of air ionized. Second, hydrogen peroxide concentration measurement. The result of the measurement is shown in the figures on the screen. As shown in the figures, concentration and yield of hydrogen peroxide increases as the voltage increases. This occurs because the electron temperature increases as the voltage increases. The increasing in temperature also increases the kinetic energy and radical intensity of hydroxyls. Hydroxyl radicals are formed due to the dissociation, ionization, and excitation of water molecules. Two hydroxyl radicals combine to form a hydrogen peroxide molecule that is more stable. Third, effect of voltage on phenol concentration. As shown in the figure, the correlation between voltage and phenol degraded can be seen. The higher the voltage, the higher the phenol reduction in wastewater. This is due to higher voltage can produce plasma maximally. Plasma formation could increase the amount of ionized gas that causes the formation of radical compounds. Hydroxyl radical has a role in the degradation of phenolic compounds in batik wastewater through some steps. Fourth, effect of catalyst type on phenol concentration. As shown in the figure, the use of iron catalyst increases the percentage of phenol reduction in wastewater. The wastewater treated with iron catalyst had a higher percentage reduction compared to the wastewater that was not treated with iron catalyst. This is due to the role of iron catalyst to transform hydrogen peroxide compound back into hydroxyl radicals through Phenol reaction. Well, the difference between the iron sulfate and iron oxide is the amount of iron ions. The wastewater treated with the ferric catalyst had a higher percentage of decreasing of phenol concentration than wastewater treated with ferrous catalyst. Fifth, the analysis of variance or ANOVA. Selection of the proper model was conducted to get ANOVA results. The model selection was carried out based on the sequential sum of the square model, the regression model suitability test using the lag of fluid test, and the statistic summary model on the response of phenol concentration. The result shows that voltage and quadratic catalyst has significant effect to the degradation of phenol concentration in Batik wastewater. 6. Analysis of surface characteristic response. The selected model can be displayed in surface contour graph and 3D surface, as can be seen in the figures. And the conclusion, the electric barrier discharge or DBD reactor can release plasma discharge between two electrodes. Plasma electrolysis process can be characterized by the presence of ignition voltage. Ignition voltage on the dielectric barrier discharge reactor used in the study occurred at 1400 volt. Therefore, the voltage used for the degradation of process of phenol compounds must be above the ignition voltage value. The higher voltage can produce a higher phenol reduction in Batik wastewater. This is due to the higher voltage can produce plasma maximally. The type of catalyst can also affect the degradation process of phenol compounds. Batik wastewater treated with iron sulfate catalyst has the highest percentage reduction in phenol concentration for about 88.73%. Well, the iron or the ferric catalyst has an important role to transform hydrogen peroxide to hydroxyl radical directly. Based on the analysis of variance or ANOVA, stress and quadratic catalyst variables affect the response of phenol levels in Batik waste. That's all for the presentation. Thank you for your attention.